Alright, this is for assignment 5. For the skybox, I added a new parameter, which was for the inside calling. So if the inside calling is false, then it basically makes the skybox, because you're looking on the inside and the outside of what the cube would be, are invisible. So then you're able to look inside. But then if it's true, it just becomes a normal cube again. So I just set that up so then I could see the differences between the two. And then I multiply that value to get the multiply that value by the length, so then I can do that length call value by everything. So then basically, like for the first line, the top right for the normal cube is the bottom left for the skybox. And then this is what I have it looking like, and I set all these manually to what the skybox was is set up. And then the length is 100, so if we start this, there is one thing though, is right now I have my filter set up as point for the nearest neighboring point because of these lines, because they're a lot thicker if I go into linear, and I can't really figure out why, because like right here it's perfectly fine, but I'm not doing like anything different in my code that I see unless if I'm completely missing it. So like the skybox works, I have these creases though at the very top and bottom. And then for my terrain, first I'm going to show just your HM test, and it's going to be a 1 by 1. I added another parameter, which is the size of the image. So 256 is the size, so 256 by 256. You just have to put it in here. So if you do this, it'll be the texture and the height map. So you'll see wherever it's white that it should go up where it's supposed to. The terrain is flipped, but how I have it set up, that makes sense to me. So if we go up here, so you'll see wherever, let me do this, wherever it's white, like it's supposed to go up higher. And then this is what your HM test texture looks like. But then if we wanted to, we could change this to the flagstones, which are stones. And then with the UVs, have the UVs for it repeat 30 times on each side for the U's and the V's. And there we go. And then if we show that, then this is what it looks like. Same thing, but now has a texture. This is seamless, but just because there's so many of them, it looks like it's repeating. As you can tell, if you get really close, you can't really see where one starts and one ends, except at the top and bottom, I guess, because of the darkish line. I made mine into just one array instead of a 2D array. Because after I had it set up, I actually understood what was going on with it. So I still have a row and column. I just had them set up individually. And then I have all these extra variables just because I set it up before I set it. So then this looks a lot cleaner and I know what's happening as it's going through. J's also implemented outside because J counts how many vertices, how many verts there are, and then has that equal I, because I keeps going in the for loop for the number of verts in general. So it just keeps going through, and then you add on to row, add on the column. And then when we're doing the try list, I have it set up like this, so then it can keep going through depending on the number of squares. So I only need these 2 for loops and then basically these lines, and then that's it. And then there's no, it does not hold the matrix at all. So if we go down here, it doesn't hold the matrix. It has its own, I have the DXApp, have the matrix, and then it goes through, and yeah, so it doesn't hold its own matrix and everything's okay.